One of the things I've wanted to do for a while is build a rocket with cluster engines. Now I do have one that I built that takes two D or E motors, which is basically a Big Daddy with two motors. But I wanted to build something that was either a bigger rocket or a clustered rocket, or bigger and a clustered rocket, but still something that would be able to fly on D or E motors. So I decided to go ahead and build a rocket that would be able to fly on four D or E motors. I was able to put the rocket together, but when it came time to fly it, I discovered there was an issue with wiring up all of the igniters to the motors. So I was at the launch site and I was not able to get the bird off the ground. However, I was told by one of the other people at the launch site that I needed to build what was called a whip that's used to split out the power from the main line to four separate connectors, one for each rocket motor. So this video that I'm putting together here is snapshots of me as I work and build the four motor cluster whip so that I can fly my rocket the next time that I want to be able to do that. Here you see the cluster rocket standing on my front deck. As you can see, it's rather tall. The fins are on the bottom. This is the motor area of the rocket at the base. You can see there's space for four motors, and there's also a motor retention system that uses a bolt. At the actual launch site, I realized that I'd forgotten to put a launch lug on the rocket, so I used a straw that I got from a vendor. Luckily they had one at a fast food place that was the right diameter. So this is the straw used for going onto the launch rail, and you can see it's way down at the base near the center of pressure of the rocket. I wanted to use my jump starter to test the ignition system, but there's some kind of a system on it that's checking for shorts apparently. So when I try and connect it to an igniter, it just won't run it, which is unfortunate because this thing has a lot of power and it's very portable. It's great for testing. After I discovered that I couldn't use the jump starter, I dug around in my box and found this power supply, which is high voltage, but the amperage is kind of low. As experimentation showed, it didn't produce enough current to be able to ignite all four igniters at once, but it did have enough current to be able to verify that the wiring was good. So for field use or for further testing, I'm going to need something with more amperage. To build the whip, there's a lot of different pieces that are necessary. So you can see up at the top right, there's two extension cords. One is white and one is brown. This was the source of the heavy-duty wiring that I needed to have to make sure I would be able to get enough current for the whip. Next to that, you see a package of electrical tape. You gotta have electrical tape when you're doing wiring. To the left, you see boxes of clips. These were clips that I got at the Harbor Freight store. The price was pretty good. The ones I ended up using are the ones on the left-hand side, and then some from the top. They have a rubber sheath and they're color-coded, which is great. You also see the connectors. These are the watertight heat shrink connectors. I used a lot of those and they're pretty darn handy. I especially like the heat shrink function. I didn't end up using the heat shrink tubing because I found some heat shrink tubings in another box, but you definitely are going to want to have heat shrink tubing for connections to make sure that dust and dirt and stuff don't get in. And then on the right hand side you see the multicolored test leads. These seem to not have enough current capacity, so I ended up not using these, but they will be available and probably something I can use for future testing. Here you see the clips that I got out of the package. There's going to need to be 8 of them total because you need 2 for each pair. These do have color-coded insulated material to go around them, kind of a heavy-duty plastic material. The clips themselves are identical, it's just that covering that differs. Here's a close-up of one of the clips. You can see that it's got a place for you to put the wire in. There's 2 little teeth that bend down to help hold the wire in place. There's also a hole where you can put a screw in, or I actually use that to solder the wire in. And then there's this plastic rubber boot that goes over it. So it's a pretty nice little setup, very nice configuration. So to start making one of the whip lines would be the ground line. I started with this brown extension cord that I got at Ollie's. It was like $3. This one I think is 9 feet long, which is plenty long enough to be able to do the whips and have some left over. So you see the clip with this in the lower right hand corner there, and also its black boot, and then the brown electrical cord that's soon going to be cut apart and used for the whips. I cut the end off the extension cord that had the outlets. This one had like 3 different outlets because I'm not going to be using that at all. The other end, which isn't shown here, is the end that actually has the 2 prongs. I thought I might need that, so I went ahead and left that intact. It turned out I didn't need it for this project, but depending on how you set up your whip, you may end up wanting to use that so that you can easily plug in and unplug from power supplies. I decided to make each of the whips about 24 inches long. That gave me plenty of space to be able to flex and work, because I want to make sure that I've got plenty of flexibility and ability to get in and out of the rocket launching areas. This whip, if it's used with other types of rockets, could be at like a high power site, for example, and I don't want to have to go through this whole rebuilding cycle again. So extra long cable is probably a good thing, just to make darn sure that you've got enough reach to get from the input to the whip to the actual end of the rocket. So I went ahead and split the electrical cord into 2 pieces, one for each wire. So there's one brown wire that's going into this alligator clip. I then used a wire stripper and stripped the end of the wire, maybe 1/4 inch or so, and then twisted it. And then I fed the wire through the hole on the clip, and then left the upper part where the insulation is still there. And you can see the little teeth are kind of bent over. You have to use a pair of either needle nose pliers or a good wire stripping tool and bend those over on both sides really, really strongly, because that gives you the mechanical strength on the alligator clip. You want to make sure your alligator clip doesn't come apart, because that would mean your rocket's not going to fire. So make sure those teeth are bent in, and you want to make sure that wire goes through. Here's a bottom view of the alligator clip. You can see how I've twisted and fed the copper through the bottom and kind of bent it towards the back of the clip. I went ahead and soldered the wire to the clip. This took some experimentation because the clip's pretty big and it takes quite a while for the clip to get really hot. So you need to look at the wattage of your soldering iron to make sure that the solder is going to adhere not only to the copper wire but also to the clip, so you make sure you have a really good connection. I did have a problem with this on some of the early cables where I checked them with my meter later and I didn't have a good enough connection, and I ended up having to cut the alligator clip off and redo it. So make darn sure that you've got this folded over and you have a hot enough solder, and you make sure that you have a really good electrical and mechanical connection of the copper wire to the clip itself, because that's how you're going to get your current from your source out to the igniter that's going to set the engine off. The next thing I did after I had connected the wire and checked that everything was good is I used some heat shrink tubing. So here you see I have some black heat shrink tubing, and I put that over the connection. So that's an added layer of protection in addition to the rubber boot that goes over it, to make sure that your wiring doesn't short out in the field, and to provide it maybe a little bit of extra mechanical strength as well. I did check these with a meter before I put the heat shrink tubing on, because you want to make sure you have that good electrical connection. Once you put the heat shrink tubing on, you really can't take it off that easily. You have to like cut it off or something. So make sure you check the electrical continuity with your meter before you put the heat shrink tubing on, so that you can make sure that you have good connection and that you're going to get a good signal. Once the black wires were done, I went on to do the white wires. So you can see here I've separated those out and I stripped the ends, and then I've got the 4 alligator clips here along with their red boots. So it seemed to kind of help to do one step at a time, that is stripping the ends all at once and such, so that you can kind of do the things in parallel. And don't forget to get out the heat shrink tubing. I found some again in another box, so I used it. Looks like there's 2 different sizes here. Make sure that you have the boot and the heat shrink tubing on the wire that is where the white insulation is before you solder it in, because you've got to make sure that you can get the heat shrink up and get it on to the connection. And you can't really feed the heat shrink tubing over the alligator clips, it's not that big. And you can't slit the heat shrink tubing and put it on, because you lose that ability to have the heat shrink tubing really form that really tight seal. So make sure you've got the boot and the heat shrink tubing in the left in this picture, and then the wire, and then that goes into the alligator clip. So after quite a bit of work, I had the 4 connections that are here with the white wire and the red boots, and then the 4 connections which have the black boots and the brown wire. And I used a meter to check these to make sure that I had good connection. So you're definitely going to want to do that. Take the other end, which isn't shown here, the other end of the cable, and use it on your meter, and then check against the clip on the alligator. And your resistance should be really, really low. And moreover, each one of the cables should have virtually the same resistance. If you've got an instance where the resistance is really high, or you get inconsistent readings, you may have a bad solder joint. At this point, you have the option of either going in and redoing the solder joint, which means you've got to take stuff all apart, or you could just say, I'm just going to cut the end off and I'm just going to redo with a whole new alligator clip. So that's up to you. If you do cut the ends off, keep in mind that your cables are not going to all be the same length, which may cause you problems out in the field. So you may want to go ahead, if you have a problem, and cut the heat shrink tubing off, and then go in and unsolder and put new heat shrink tubing on after you resolder. But don't put the heat shrink tubing on until you've verified it with a meter to make sure you have good connectivity and the insulation is all good, and that your resistance is really, really low. Because you have to have low resistance to be able to get the current to the igniter to make sure that the motors ignite at the right time. Because you're going to have a lot of wires, you're probably going to have to use these connectors. So you want to make sure that you have a good electrical and mechanical connection. These connectors are designed such that you can feed the wires in from each side, use a crimping tool to crimp them down tight, and you have a good mechanical and electrical connection. These also have the advantages. They have heat shrink tubing on them, which I didn't notice when I bought them, but it's an added bonus. You can use your soldering iron once you're sure that you have a good connection, and you can set the heat shrink tubing up, and it also adds a little bit more waterproof protection. So if you're out in the field and a little bit of moisture is around, it's not going to cause your rocket to have a malfunction. So I really recommend these connectors. These are great. I got these at Harbor Freight, and they worked really well. You see here 2 ends on the whips. Because of the way that I wanted to have the final connection, I wanted to have 2 big clips that went to the supply, or the signal from the ignition, the rocket ignition system at the control panel, that then fanned out into the whip with the pairs, 1 pair for each motor. So because of that, I'm using a kind of a ganging mechanism where I'm putting multiple cables into the same little connector, the same butt connector there. So these 2 ends are from 2 separate cables, and you can see I've stripped them and twisted them. So this is a preparation for actually putting them into the connector and crimping them down. So here you can see I've twisted the 2 different ends together from the 2 different width cables, and you can see the connector on the left. This is just before I slid the 2 different wires into it. You got to make sure that the wire isn't too long, but you want to make sure that the wiring gets up into that metal section, into there really good, so that when you do the crimping you get a really good connection, and that preferably some of the metal is also crimping down on the insulated plastic to give it that mechanical connection as well as the electrical connection. This took some experimentation to get it just right. So here's the crimped connection. You can see the 2 different cables coming in from the left. They're going into the metal in the center, and then they're crimped down. This is my wire stripping and crimping tool that I had in my box. Very, very handy to have. If you don't have one of these, you definitely want to get one. Now you see, if you look at the connector, that it looked like it's only got crimped once. I later, in the later ones, and I went back to this one, crimped it twice, because I wanted to make darn sure that I had a good mechanical as well as electrical connection. Again, I don't want these things coming apart in the field I want to make sure they're really clamped down well. So you may want to go ahead and do that same method yourself. Is once you have the wires in, is crimp them twice at the same side, of course, of the connection, so that you have a good electrical and mechanical connection. Now the next thing that has to be done once you have the two wires coming into the single connector is you have to put in a short cable, which is here, it's like 3 or 4 inches long, and you see there's two different ends. This allows you to connect two of the other cables. So basically you have two cables going into one, and you have two of those, and then you go down to a single cable at the end. So you are making kind of a consolidation of all of the cables down to one. That way your whips are set up as parallel, not as a serial kind of connection, so that all of the igniters are separate, but they do have this common connection that goes back, in this case, to power. You'll be able to see this better in the next couple of pictures. Okay, so now you can see on the left we have the two wires. Each one of those is a whip that ends in an alligator clip, and that goes into the connector. And then on the right we have the short connector, the short wire for the connection, and that's in, and that got crimped so that this takes the two whips, brings it down to a single wire that then can be used to kind of the final connection between the two. Here I'm using my multimeter to check the resistance on the wiring. You can see I've got two different red cables here. These are the ones that I just made, so I'm checking to make sure that there's a good path between the two alligator clips, just as part of the testing procedure, to make sure that I've got good electrical connections everywhere. So here I'm doing another test. This is from the end where I've done the 2-to-1 connection, and the other end is one of the whips. So I'm verifying that I have good connectivity from the whip down through the joint and then to the end. So it looks pretty good in that case. In fact, I think the resistance is slightly lower than between the two ends. So this is the path that the current's going to flow. It's going to flow like from the upper right where my thumb is, down across that connection and to the alligator clip. So you want to make sure that that has low resistance and it's a really good connection, because that's where your current's going to go. It's going to set off the igniter. Here you can see the result of using the soldering iron on the heat shrink on the connector. I used it to shrink the connection down on the left and the right to try and get it to be as air and watertight as possible. So that helps to keep the moisture out and helps to make sure you have a good connection when you're out in the field. Here you see the later stage. On the left hand side we've got the 4 cables going into the connectors that then produce one cable on the right hand side, and then those 2 cables on the right hand side are going to go into another connector, such that eventually you get down to the single wire, which is going to go to the alligator clip, which is then going to go to the ignition system on the control panel. So it's got several joints along here. Rather than twisting the wire myself and putting a bunch of solder on, I did use these connectors, and I think that it's a better choice because it gives better mechanical and electrical connection, and making sure that those are really good. So you can see everything is pretty much set up here. You can see the 2 wires are twisted up at the top, and the extra connector is just kind of sitting here on the table ready to be used. So once I've got all of the whips connected from the 2 down to the connection to the final long wire, I've got to put the big clamps on, the big clips on the end. For this I use the much larger clips you see here. I wanted to make sure that I would have a good ability to connect even to something like a battery terminal, and the other little connectors that are set up for the igniters and the rocket end of things are not suitable here. So I use the 2 bigger connectors from the kit for this end of the whip. Okay, here you can see the positive side of things. I've got the connector with the red boots and with some red heat shrink tubing and the white wire. So this is all ready before I'm going to go ahead and attach the wire to the clip and solder it in and make sure everything is good. Here you see a good shot of how the wire is held in place by the teeth on this bigger battery type alligator clip. you also see a terrible mistake that I made. Well, not a really terrible mistake, but a little bit of a mistake I made. You can see the rubber boot and the piece of heat shrink tubing are on the desk. Obviously, those need to be where my left thumb is in this picture. I left them on the desk and I didn't notice until I had the little teeth folded down. So I thought I had the choice of bending the teeth up and risking snapping them off, or just going with what this is and just using tape. If I had to do it over again, I probably would undo these, and just if the teeth broke off, I just use another connector. So make sure that you have the heat shrink tubing and the boot on the wire before you put the wire connector in like this, so that you can take advantage of the heat shrink tubing and have the boot over things. Here you see the back of the connection, one of the whips, when I was just showing earlier. For the hot side, that is the plus side, you can see this is the back where the copper wire is coming through that hole, and this is before I applied the solder to make the electrical connection. Here you see the back side of the connection for that whip. After I soldered it, this is still kind of messy looking, and I think I actually heated this up and added more solder. Again, this clip's really big, so you have to have a good high wattage soldering iron and wait for a while to get it really hot so you have that good electrical and mechanical connection. Because if this connection, the solder connection, is flaky, you're not going to have a good ignition of your rocket, and it's just going to sit there on the pad. So you got to make sure this solder connection is really, really good, as well as the mechanical connection with those little teeth that fold over on the other side. You can see here that I also applied solder on the inside, where the wire kind of goes through that hole to the back. I did see this on a YouTube video, and the guy soldered his wires in this way. So I figured I've got it soldered on the back side, I've got it soldered on the inside. If you heat it, you can make sure you have a really good connection on the top and the bottom, and you have that good electrical and mechanical connection. If you get too much solder, it kind of makes a little bit of a mess, and you can kind of get it to tap off if you've got too much. But I think this is a really good approach to solder it both on the top and the bottom to make sure that you've got that really good electrical and mechanical connection. This is the connection of the ground side of things to the big alligator clip, and you can see I've pretty much done the same thing with the gripping teeth there and folded them over, and I fed the wire, the stripped copper wire, through the clip so that that can be soldered in place. Here's the bottom side of that clip before I applied any solder. You can see there's a goodly amount of wire in there, and it's held in place by the teeth. So this is a good mechanical connection of the insulation and the wiring in before the solder is applied. Here's the connection after I put the solder on and I got it good and hot. You can see the solder is bound pretty well to the bottom of this connector. This is a really good connection, probably better than the other one. Like I said, I think I did the other one to be more like this, so that they both have really good connections mechanically and electrically. So after the soldering is done and I've checked things out with a meter, the next step is to get the heat shrink tubing on. So here you see I've got the heat shrink tubing I put onto the black larger connection, the one that looks like it goes to a battery terminal, and I've used a soldering iron to kind of heat this and get it to bond to it better. So out on the front deck for testing, here's the white cable. You can see that I had to put black tape on the end of the big clip here. That's because I didn't have the heat shrink tubing on it again. So it's got a bunch of black tape around it instead of the heat shrink tubing. But it does have the red on the other clip, so yeah. And you can see how the four leads with the small clips on them are out, and then those are fed into the connectors, and then another connector, and then that goes down to the big clip. So this has a pretty long reach. It should be plenty long enough to go from the rocket that's on the stand to where you have the cables from the actual control panel. So here's the neutral or the minus side of things, I guess. You can see the four small alligator clips on here. You can see the bigger battery connector type of clip on there. You also can see that the rubber boot has kind of slid down, but you can see that the heat shrink tubing is still protecting the operator there. So that just looks aesthetically better and is probably safer as well. So here's the other half of the cable. You can see in this picture how I've used some black tape to connect the two pair, here the black and the red, for the long cable that goes to the supply or the input. So I've connected that so I don't have a bunch of little wires kind of flip-flopping around. That I've definitely got the pair with the two different connectors. So these connectors are going to be the ones that connect to the output from the controls on the launch panel. In this picture you can see how I've set up the pairs so that there's 4 pairs. That's one pair for each motor, because you've got to have 2 connections there to make the circuit. So each of these is in parallel, and they go down to the inputs from the control panel. So you see each one has a black and a red. I did have to kind of wiggle these a little bit to make sure that they didn't cross over each other in awkward fashions, because I've got that connection from the 2 down to the 2 and then down to the 1. But these actually seem pretty practical. They're not all quite the same length because I had to redo a couple of them. So 2 of the whites are a little bit shorter than the other ones, but from a standpoint of out on the rocket field, they're just like a 1/4 of an inch shorter, so it shouldn't be a factor. But you can see here I've got 4 cables, 4 pairs. Each one of these can be used for a motor, so this can be used for 2 motor clusters, 3 motor cluster, or a 4 motor cluster. In theory, that is, assuming that your power supply can put out enough current. Here you see the results of the 4 igniter test, where I put 4 igniters connected up to the 4 pairs, and you can see that the igniters have, many of them at least, have burned through. There's one of them that didn't burn through, and I'm pretty sure that's not a wiring issue per se with the ends. I think it's just because the power supply wasn't beefy enough, it didn't have enough current to be able to burn through all 4 of them at once. So here you can see where plenty of current went through this igniter. It's burned pretty well. The end has definitely gotten hot, and the wires themselves have gotten really hot. You can see that they burned through the paper. That's because I held the power on longer, a lot longer than you would in an actual rocket launch. I've never seen the paper burn like this, because usually the rocket takes off well before the wire gets hot enough to burn the paper. So this is just an example of me holding the fire button down a long time, and plenty of current going through these and actually setting them on fire. So here's the igniter that didn't ignite. You can see it looks pretty much intact. The paper obviously is not burned. So again, either the igniter itself was defective, or there just wasn't enough current going through because the power supply wasn't beefy enough to ignite this guy. So now we come to the actual test with motors. I wanted to check and see if I could actually get honest-to-goodness motors to ignite here using the WIMP. So these are the smallest, wimpiest motors that I had in my box. Relatively inexpensive for this testing. These are A34Ts, pretty small motors that I use with a little bitty Estes rocket. Here you can see how I have the motors kind of held together with a couple of rubber bands, and then I have the standard Estes igniters in the motors with the little plugs, and then the wires are out to the sides. That's to make it easy for me to connect up the alligator clips so that I can do the testing. So side view of the motors here, yay for rubber bands. I want to make sure that the motors were all held together by something pretty sturdy. So here they are held together. Here you can see how I used a goodly supply of black electrical tape to fasten the motors in a plate. This is a bowl, it's some kind of a ceramic, so it's not flammable. So when the motors fire and the injection charge goes, there's no danger of setting anything on fire. But the motors are also fastened in pretty securely, so they're not going to go flying all around my deck and cause excitement that's unnecessary, and possibly pull my wires free. So this is the setup. Here you see the setup with the wires, and you can see that each motor has a pair, a black and a red, connected, and that the wires are kind of held in again with a little bit of tape so that they don't go flip-flopping all over everywhere. Out in the field, probably be a good idea to bring some blue tape along with you so that you can connect up all of your cabling, but at the same time make sure that nothing is going to short across and cause you any problems. Usually you don't have that if you have a single motor, but with the cluster like this, you're going to want to make sure that all of your wires are separate and that you don't have any shorts between the ignition, because if you do, either nothing's going to work or one of your motors is not going to ignite and your cluster is not going to work the way that you want it to. So here you see a still from the video where I recorded the actual test firing of the motors. I discovered that not all the motors fired at the same time, probably again due to the insufficient current from the power supply, where for some reason one of the igniters got to be hot enough to set the motor off, so these light off in sequence. But you can see the motor is igniting, so we've definitely got connectivity here, and we've got enough power getting in to at least ignite this motor. So here you see the aftermath of the testing. All the wires and everything are fine. The igniters are there in the plate. There's a little bit of ash and soot around, but by and large this was a pretty safe test, didn't go anywhere. Did have the motors ignite, all four of them. So it showed that at least I have good connectivity, and like I said, I think the issue is just the battery, or in this case the power supply, didn't have enough current.